So let's get started. I'm going to start with a small presentation and show you what we are going to do today. And I want to issue a warning. Yesterday, I mentioned an altcoin called Bitcoin Cash. I did mention it even a few times. And I feel that I wasn't clear enough on this point. Bitcoin Cash is a scam, if you ask me. They have very few developers, hardly any review process, and it is centralized. If it would ever become popular, it would have a centralized effect on the network because it will be harder and harder to run a full node, the more transactions that are floating around, because the blocks will get bigger and bigger and bigger, and it will be harder and harder for normal people with normal hardware to verify the blockchain. And they ripped out important parts like SegWit from the code, so they can't build advanced protocols on top of this blockchain, and it's easily attacked because it only has something like 1% of the hash power of Bitcoin. So you can take old Bitcoin miners and attack the Bitcoin Cash network, and they also have a charismatic leader. I mean, they have one leader that's very passionate and well-spoken, and he reminds me very much of someone who sells snake oil. So please be careful with this altcoin. So stay away from it if you can. I hope I'm clear about where I stand on this, at least. Okay, let's discuss today's labs. We will do labs in two parts. The first part, we will download, verify, and run Bitcoin Core on Signet. And Signet is a network. It's a test network for test Bitcoin, so you can't do any real harm. It's not real money, so it's just test coins. So download, verify, and run Bitcoin Core on your own computers. And we will do that on the command line. So we will not use a graphical user interface today. There is a graphical user interface for Bitcoin Core, but we want to get down to basics here today. And we will create and back up a wallet, and we will you will receive and send coins among each other in your group. But first, I will go through part one myself as a demo, and then you will more or less repeat what I did. So that's part one. After part one, we are all set up with our full nodes and our wallets. So that's a good checkpoint to have. And after part one, we will do part two, where you will do assignments. And I have made a list of various tasks that you can do. And you may choose several of these in any order. Choose the ones that catches your interest and do them together in your groups. And I have written instructions for this. I put the instructions on my web server, and you should load this file in your web browser, because I might need to make updates to it. So, and if I do, you can just hit refresh in your web browser. So it would be a smooth upgrade process. This is also in the instructions, these resources. So I just mentioned them here too. Some good resources that you could use for the labs is, of course, my book, Grokking Bitcoin, and Bitcoin.org has a very nice tutorial for how to set up your own full node. And it has specific instructions for different operating systems, one for Mac OS, one for Windows, and one for Linux. So this is really good, and I encourage you to look that up. Of course, Googling. And there's a wiki called, well, I call it the Bitcoin wiki, but it's a very good resource. It looks like this. So, for example, here's the transaction. They if you want to look up bytes, how for example, transactions are laid out, how the bytes are laid out, you can look it up at this Bitcoin wiki. And also if you want to explore the network protocol, you have a lot of resources there too. So for example, here are all the network messages, so protocol documentation and so on. So I really recommend this wiki site. It's not very flashy, but it's very informative and technical. Now back to the slides. And part one will happen like this. I will do part one in whole in the main room in front of all of you. And then we will create breakout sessions where you do it yourself in your groups and help each other out. First of all, if you're not running Linux, or Mac OS will work too, you should look up the instructions for installing a full node on this link here. Maybe I should increase the font a bit, like this. So I will just get started. So we will download, verify, and run Bitcoin Core now. And to do that, we need to get the latest version of Bitcoin Core from bitcoincore.org, which is here. You go to bitcoincore.org like this, and you hit download, and here's the Linux tar.gz file. So I copy this link, and I go to a command line. It's very important that you can read my command line here. Is it readable to you? What did I write here? Hello, good. So the first thing, I'm now in my home directory. I will be working from my home directory. I don't have anything here. So I will start by downloading this software that I just copied the link for. And while that's downloading, I'm going to the bitcoincore.org's website, and I will also download the signature file, which is here, verify release signatures. This is a link to the SHA-256sums.asc. Copy link address. And I will download that too, like that. So back to the script here. And as you recall from the lecture on chapter 8, we downloaded the program and we have downloaded the SHA-256sums file, which contains the signatures and the hashes for the program. So I will show that here. Here this we'll do cat SHA-256sums. I will expand this window a bit like this. So this is the full file. It starts with a message up here. This is a message, and this is a signature for the message. This signature is done with the Bitcoin Core release key. And as you can see here, in my presentation, there was only one hash and one file name in this file. That was a simplification. It's actually multiple files here. One file for each architecture and operating system. So if you're running Mac OS, you should be downloading this one. And if you're running Linux, you should be running this one. And Windows should be, actually, I'm not sure if it's this one or this one. Anyway, so this is the signature file. And to verify that this hash matches the hash of my downloaded file here, I will use a program called SHA-256-SUM. And -C for check, and I'll just skip that. So we'll do like this, and it will say a lot of things here, as you can see. It says no such file or directory, failed open or read, and so on. But it said okay. For my file, it said okay. So this is a pretty. So if I don't want all this, because I haven't downloaded this file, for example, so that's why it can't find it. I will do this again. So SHA-256 knows how to verify this a list of files like this. So if I give it a list, it will verify the file names in that list against the corresponding hashes. I can also do it like this: SHA-256 and my this is a more manual process. So I hash my file here to see what I get, and I get 36, 6E, B4, and so on. And then I have to manually verify that it corresponds to this hash here, which it does. So now I have verified that. The next thing we need to do is that we need to verify the signature as well. And that's how you do that depends on who you know and where you are and a lot of stuff. You need to make sure that you have the correct public key to verify this signature with. And in the book, it says that it's this fingerprint. In Grokking Bitcoin, I write that it's this fingerprint, but you should verify this from multiple sources. So you could look it up in the book, and you can ask people on forums, ask someone you trust, and check on bitcoincore.org's website. That's a given. So let's go to bitcoin.org's website and have a look there. So we are now on bitcoin.org, and we have a secure connection. And they publish their fingerprint down here. And this is the same fingerprint as the one in my instructions, which are here. I have already verified this, but so I should verify this with multiple sources. So when I have done that, okay, I see that I have a wrapping issue here. Yeah, so make sure, be careful with wrapping here. The web browser will wrap long lines. So I use a program called Gpg to download a key with a certain fingerprint. And I haven't said that, but a fingerprint is just a hash of a public key. So it's a public key hash, but not the public key hash you're used to. This is, how long is this? I think it's 128 bits. I'm not sure. You'll have to count the numbers here. Anyway, so you use this Gpg program, which is a program for managing keys and signing stuff and verify signatures and stuff. So what we got here when I ran this Gpg command was that we got a public key belonging to Vladimir van der Laan, which we talked about the other day. So we now have this key, and we have verified with multiple sources that this is in fact the the fingerprint we expect. And I can do Gpg list keys if you want. So I only have one key in this Gpg, in my Gpg data. And this is the key that I just downloaded. So now we have downloaded the key and it's time to verify the signature. So we will do Gpg Verify, and we will verify this file here. And this file is a standard format. It has a message part at the top and a signature part at the bottom. And Gpg knows how to parse that. So it knows what is the message and what is the signature. And it will say something like good signature for Vladimir van der Laan, and so on. And it also says this key is not certified with a trusted signature. This means that you haven't signed this key yourself. You can create an own identity. You can create an own key pair that represents you. And with that key pair, which is then ultimately trusted, you can sign this this Vladimir key. And when you have signed that with your key, Gpg will regard this key as trusted. But we won't do that here. You have at least verified that you have verified the fingerprint with multiple sources, and we settle with that for now. But if you want Gpg to remember that you have trusted this once, you can sign it with your own key so that it will be remembered. Because when you come back in 2 years and you want to upgrade Bitcoin, you might not remember if you actually verified this fingerprint or not. Someone asks on SHA-256 sum is not on Mac OS. I suggest that you go to the full node, to this site here, to Bitcoin course site. I didn't say that. I should have said it. Sorry, I forgot about it. And here on the download page, you have this verify your download right here. And there you have some Mac OS instructions. So you do it like this instead. Yeah, someone else answered that too. Good. So, and if you're on Windows, there are instructions for that too. Okay. So now we have verified the software. Sorry, that's the one. No, that's not the one. This one. Okay, so now it's time to unpack and start Bitcoin Core. So we'll start by unpacking it. And as you see, it will unpack a number of files here. The most important files that we're going to care about is this one and this one. This one is the GUI, graphical user interface of Bitcoin. So you run either this one or you run this one. So this one is headless and this one is with a graphical user interface. And this one, Bitcoin CLI, is the one we're gonna use most today. This is a command line interface that communicates with your Bitcoin D. So we're gonna go into Bitcoin 21.1/bin. And we're going to start Bitcoin D with signet and daemon. So this tells Bitcoin D to start on this test net, this testing network called Signet. And daemon tells Bitcoin D to start in the background. So that's not, just start in the background and keep running in the background. So we'll do that, and it says Bitcoin Core starting. So and we can now run, we can use the command line interface. And for every command you do with Bitcoin CLI, you have to append this or use this -signet flag. So let's have a look at the basic command, get blockchain info. It will give us some info about the blockchain. So it says here that we're on chain Signet. It has downloaded this many blocks and this many headers. So right now it has downloaded the full chain of headers, and now it's trying to fetch the blocks from peers. And this is the tip of the blockchain, current difficulty. And it says here, initial block download, true, which means it hasn't synced. It hasn't finished syncing yet. So this is not a fully fledged participant of the peer-to-peer network yet. And here you can see some old soft forks that we talked about, BIP34, for example, 65, CSV, Segwit, and then we have the ongoing Taproot. Actually, it says active here because this is on Signet. So Taproot has already activated on Signet. We won't be using Taproot though. All right. So if we have a look again, it should have downloaded all the blocks at this point. No, it hasn't. So it's still initial blockchain download. Never mind. Okay, so we have started it, and we have looked at the blockchain info, and we can also stop it. Like this. So we're stopping Bitcoin Core, and to get rid to not have it, we don't want to enter this -signet every time. So we will put that in a configuration file, and there is a configuration file called bitcoin.conf. So we will do like this. We will set chain equals signet in .bitcoin/bitcoin.conf in your home directory. So I'll have a look. I'll show you this file here. So we just created this file, and it contains now only chain equals signet. That means we will run signet by default. And we also want to, for the labs, we want something called the TX index to be enabled, because we want to be able to inspect arbitrary transactions in the blockchains later. And for that, it's good to have the transaction index. Otherwise, you won't be able to fetch arbitrary transactions from your blockchain. So we'll do that too. And then we will start again. And this time we can do only like this without the -signet. So now it's starting again. And again, let's have a look at blockchain info. Okay, what did I do? Oh, all right. I shouldn't have signet here. So I got yeah, the signet was used twice, which was probably bad for some reason. Yeah, so as you can see here, we have 45,800 blocks, which matches the number of headers, and it says that it's not in initial block download anymore. So we are now up to date with the blockchain, which is nice. Okay, so now we have started our Bitcoin core, but we have no wallets yet. We need to create a wallet on this beast. And before we do that, I want to tell you about the help system, which looks like this. I will pipe it to less because it's quite long. And just typing Bitcoin CLI help will give you a short summary of every command available. And they are grouped by category like this. So if you want to inspect something about the blockchain, you have these nice commands here, and some daemon control stuff. And if you're into mining, you can use these things here, but you probably shouldn't be mining on an ordinary laptop. And some network stuff, ways to handle transactions. I mean, you can build transactions, you can inspect transactions. And you see this term a lot everywhere. PSBT, partially signed Bitcoin transaction, and that is somewhat new to Bitcoin. It's a format. It's a BIP 174, I think it is. It's a standardized way to communicate transactions between devices. So a Bitcoin core can create an unsigned transaction in the form of a partially signed Bitcoin transaction and send that PSBT. And then you can send that PSBT to an offline signing device, which knows the PSBT format and knows how to interpret that. And in the PSBT, there is information about which keys to use, which paths to use, key paths, and everything needed for signing this transaction, except the private key, of course. So the offline signing device will be able to find its correct private key and sign the transaction and update the PSBT with the signatures. And then it can be sent back to the online device for assembly, so that the online device can then assemble a proper transaction to send out on the Bitcoin network. So that's the general idea of a PSBT. It's a very much needed standard. But we won't be using PSBTs today unless you are eager to try it out, because maybe you, yeah. So that's it. Some general utils, and at the bottom here you have the wallet section. This is the section where that handles a specific wallet or wallets. So, for example, we will be using this command, create wallet. And you have a lot of commands for the wallets, as you can see here. So we will be using create wallet, as I said. And to get more information on this, we will run Bitcoin CLI help create wallet. So you will be using this help system a lot today to find the information, to find the tools you need to fulfill your tasks. So you're going to use this extensively. And sometimes the lines are pretty long like this, as you can see, and so it can be quite annoying. But you'll have to live with that. So create wallet takes a number of arguments. First, it takes a wallet name, which is the only required argument. And then you have a few optional arguments. And we will use this argument, of course, wallet name. We will call the wallet Grok, for example. And then we also want to, I mean, these are default false and we don't care about this, but we do care about this one because we want to encrypt this wallet with a passphrase. Because if someone gets access to my computer and it's not encrypted, then they will be able to get my private keys from my wallet, and that's not good. So I want to encrypt the wallet with a passphrase, and I think that's what we want to do. We also want load on startup actually, but it's not required. We can add it later to the wallet, but as soon as Bitcoin Core starts, we want it to load on startup. Actually, let's skip that. Let's not bother with that. So we will use this and this, and it's a bit quirky actually. I'm gonna copy this up until that. So we want to do Bitcoin CLI create wallet, and we want to call it Grok, and disable private keys. We want it to be false, and blank should be false. And then we want a passphrase. We could, if we wanted to, write a passphrase here like this, but then it will be recorded in my bash history. So if I write echo hello here, and I do look at my history, it will list my 3 last commands. And if I write the password on the command line like this, it will end up in my history and eventually in a file on my file system, which is not good. So instead, I will add a flag called -stdin. That means that it will read remaining arguments from standard input like this. So here I can write my password, for example, Bitcoin. So this is my passphrase. I strongly suggest that you use a better passphrase. And then to mark the end of the input, you hit Ctrl-D twice. So now it has, and I get this back. It says name Grok, which means, okay, this is created now. So let's have a look. Where were we? Yeah, we have created a wallet. Let's get some wallet info. So we see the wallet name here, and we have a balance, which is 0. We haven't received any coins yet. There are no transactions concerning us. Which we have it is an HD wallet. We do have an HD seed, but this is not the seed itself, but a descript, probably a hash of the seed or something like that. I don't know what it actually how it, but yeah, that's the seed ID at least. And it says here private keys enabled, and this means that this wallet manages its own private keys. You can have a watch-only wallet with just an XPub and have an offline signing device with the XPRV. So that's the wallet, and now we want to back up the wallet. And this is important, of course. When I talked about backup on the very first day, or was it the second, when we talked about wallets, I said that wallets generally create a mnemonic phrase that you write down on a piece of paper and you put in a safe. The irony of this is that Bitcoin Core doesn't do this. Bitcoin Core, when to back up Bitcoin Core, a Bitcoin Core wallet, you make a full backup of the wallet file. Let's have a look at the wallet file. Let's go to the home directory and transcend into .bitcoin/signet. Here you have some stuff. For example, yeah, you have the wallets directory here. And here you have the wallet called Grok. And this is your wallet file, wallet.dat. The other stuff is just it's generated data. So the important stuff here that you need to keep is wallet.dat. It doesn't only contain the seed, it contains other stuff. It contains some metadata about your wallet. Maybe you have labels on your transactions or addresses. Stuff like that is also stored here. So let's go back to the bin directory, and we want to do, if you have any questions, just ask them in the chat while we're working here. Bitcoin CLI backup, backup wallet, and then where I want to store the wallet file, the wallet backup. So I call it wallet backup.dat, like this, and now it has made I'll make a long listing here. So you have this wallet backup here. And as you can see, it's not small, it's a megabyte in size. But you should take this backup now and move it to a safe place. And this is encrypted with your passphrase. So you need to keep track of both this wallet backup.dat and the passphrase. If you keep your wallet file in a very safe place, you could store it together with a passphrase if you want to, and that would give you about the same security as storing a mnemonic phrase. But if you want something extra security, you can store the backup file separately and the passphrase in another place. Maybe in a password manager or something. It all depends on your circumstances. How much money do you store? What's your risks, etc., etc. So this should be backed up, copied to a safe place. So now it's time to receive some Bitcoin. We're going to receive some Bitcoin and we're going to send some Bitcoin. So I will now generate myself an address. And this wallet by default will use SegWit's pay-to-witness public key hash addresses. And since we are on test coins, the addresses will look slightly different because they don't start with BC. These ones start with TB, which stands for test Bitcoin. So that you don't accidentally so that you don't accidentally send real Bitcoin to a test Bitcoin address, because that would be disastrous. Is there any reason as to why Bitcoin Core doesn't produce the mnemonic phrase? Yes, I think the rationale for this is that they don't think it's good enough for Bitcoin Core, because Bitcoin Core is often used by corporations and big exchanges and stuff like that, and they store a lot of metadata along with their wallets. And I mean, with the mnemonic phrase, the only thing you can do is to recreate the tree of keys. You don't, if you have named keys and accounts and stuff like that, you will lose that when you lose your wallet. So with this kind of backup, you keep the metadata. For example, when the wallet was created, is very important. When you, or not very important, but quite important, quite good to have at least. If you have the date when the seed was created, you know from where you can start scanning the blockchain for your funds. You don't have to scan the blockchain all the way back from block zero. You can, if you created a wallet just a month ago, you just have to scan a tiny fraction of the blockchain. So that's one reason. I think that's the main reason. So as you can see here, I have a new address here, and it's time to send some coins to that address. And I have this other wallet that I use with some coins in, as you can see here. So I'm gonna now, let's see if I can get this correct. I'm gonna copy this address here, and I want to send 5 Bitcoin to it. So arguments to Bitcoin CLI are JSON arguments. So this is a JSON array. It expects an array. This particular command expects an array here with an array of objects, and each property of that object should be either an address or something called data. But yeah, so it's JSON arguments. Okay, let's see if this is. You know what? Before I do this, I'll just mention that before you start using your private keys, I would be using my private keys when I send funds, right? So before that, as you recall, the wallet is locked. The private keys are locked with your passphrase, and before you use your private keys, you need to unlock the wallet. And you do that by wallet passphrase command. I will see if I have it here somewhere. Yeah, it's wallet passphrase like this. Bitcoin CLI STD in wallet passphrase. And it expects a number of, it expects two inputs. First of all, it expects the wallet passphrase itself. And in this case, I just have this Rosenbaum here. And I want to unlock it for example, 300 seconds. And to mark the end of the input, I hit Control D. So wallet passphrase is Rosenbaum followed by 300 seconds. And after this timeout of 300 seconds, it will automatically lock the keys again with my passphrase. So it's now available in RAM. The unencrypted wallet is now available in RAM for 5 minutes. And then let's say that you do your send stuff. So now I should be able to send coins like this. It says, and I get a reply, transaction ID. This is the transaction ID that was created. And it's complete. Meaning that it has all the signatures in it that's needed to send out. So it's now these coins are sent. And when I have done that, I should lock the wallet again. So now I have locked the wallet. But if I forget to lock the wallet, it will automatically be locked after 300 seconds. But during these labs, I suggest that you do this for something like a very 500,000 seconds or so, because you will need your private keys a lot, and it's just do that so that you don't have to add your wallet passphrase all the time. This is also in the instructions. So someone asks, isn't Bitcoin Qt easier to use? It is in many ways, but it's also incomplete. You can't do everything in Bitcoin Qt that you can do on Bitcoin CLI. But for a normal wallet management, I mean, you just send and receive coins and do stuff like that. It is somewhat easier to use. It depends on what you want to do. If you want to do automate stuff and do it over, I mean, send coins to 10 different people automatically, then it's much better to use Bitcoin CLI. But it's also a matter of taste, I guess. I recommend that you check out Bitcoin Qt, try it out for that matter. But I want to show you, I want you to do this on the command line so that you get accustomed with it, because you will most likely need to understand how Bitcoin Core works. If you work anything with Bitcoin, you should probably have your own node running, and doing that without a GUI, graphical user interface, is often more practical. Okay, so I have, let's go to my wallet here and do get balances. Untrusted pending, five coins. It means it's pending. It's not confirmed yet. And we can have a look at my transactions in my wallet. So I have one transaction. It's a category received, so it's incoming. It has 0 confirmations. Trusted false means that this output that belongs to me is created by some other wallet that this wallet doesn't trust. So this wallet will expect that this output might be removed by some. It might not confirm. It might be replaced by some other transaction. So stuff can happen with this one because we are not in control over this transaction. It's not ours. It's initiated from some other software. Okay, so yeah, and before we can spend, that's an important part here. Before we can spend untrusted outputs, they need to confirm. So that's just how Bitcoin Core does it. Other wallets might allow you to spend untrusted outputs and pending outputs. So, but Bitcoin Core doesn't, unless you have created the output yourself. For example, if you make a payment to yourself within the same wallet, it will regard that output as trusted because it was you who created it. So it's still unconfirmed, and but while we do that, I will send the money back to this other wallet. So I get the new address from my other wallet, and I will prepare send. There are different send commands. We can use send to address instead, just to show you another way to send. Let's see if I have my cheating notes here. Address equals this, amount equals 5, and I might want to set some fee rate equals 1.4. And note here that I write address equals, amount equals. So these are named arguments. Instead of positional arguments, you can use named arguments like this. And that's useful when the arguments list is long and you just want to use a few of those arguments. And the arguments aren't consecutive. So then you can use named arguments like this. But if you do that, you need to use the flag named. Send to address, amount, fee rate. And so this is an interesting thing. You have exactly 5, I have exactly 5 Bitcoins, and I want to send all the funds to this other address. But I don't have any coins left to pay for the transaction fee. And of course, I could do it like this. I could do send, say, 4.999 coins like this, and set an absolute fee of 4.00 or 0.001. But that's hard. And usually you want to set a specific fee rate, which means how many Satoshis per virtual byte that you want to pay for this transaction. So we talked about fees and how miners care about Satoshis per byte. They care about the size of the transaction. And I don't know beforehand how big my transaction is going to be. So I can't tell what absolute fee to pay in this transaction. So instead of doing that, I can just say that, okay, I want to send 5 amounts, amount 5. And I want this fee rate 1.4 Satoshis per byte. But I also want to use this argument, subtract amount from, subtract fee from amount, subtract fee from amount equals true, right? Yes. So now it might say, if it's still not confirmed, it will say that I don't have enough funds. Okay, I haven't done this also. So this is, if you don't enter your wallet passphrase, it will tell you that you need to enter the wallet passphrase first. So I'll do that. What was the fee for the last transaction? Yeah, 1 moment. And I will use 500,000 here. And I'll try again. Now it says insufficient funds, which was expected since this is not confirmed yet. So we'll have to wait until this is confirmed. And you want to know what the fee for the last transaction, the one I sent from here, right? Actually, I can't see that easily. Well, I don't know how to find that really in Bitcoin Core, to be honest. Because what you see, if you inspect a certain transaction, let's have a look at this transaction here. Raw transaction. Like this, we can have a look at the transaction. I will pipe it to less as well. So you get a lot of information about the transaction itself here, but you can't see the fee. And I suspect that's because Bitcoin Core Bitcoin Core will only show me the transaction itself, and that transaction doesn't know the amounts spent. It can only see the amounts in the outputs here. Here, the value there and the value there. But it doesn't say what the actual fee was. Yeah, nice. Someone found this in a block explorer. So that's a nice way to look at transactions is to go to a block explorer like this. So this guy Sandipan found my transaction here. And here it will say, of course, what my fee was. If we look at the details here, no. For some reason, I can't. Oh, this is the address. We need to go to the transaction itself. So here's the transaction. And the size of the transaction is 222 bytes. Let's compare that with what we have here. You see here, size 222, a virtual size 141. It's the same as we have here. And the fees here, it says 0.000 0.00182 signet Bitcoin. So that's 1.3 Satoshi per virtual byte. I don't know why, because I entered 1.4 here. I don't know why we have this discrepancy between this interface, what this says here, and what this is here. But at least it's roughly the same. But this is the absolute fee for this one. So let's see again if our it's still not confirmed. So I have to I think I don't have to show you that. I mean, we have this command here, but I have insufficient funds. But this was the last thing I wanted to show you guys. So we can just leave that for now, I think. Let's see if there was something else I wanted to do. We have received and sent some Bitcoin. Yeah, and then when you are done, you do this CLI wallet lock. And I write some in these instructions, I have some information regarding each or some of the commands. Someone asks, how do we get Bitcoins in our wallet? Yes, I will send you Bitcoins. When you have set up your wallet and created an address, when all participants of your group has an address, you will send me a list. I have written about it in the instructions. You send me a list and I will send coins to the whole group at once. So you will get five test coins each. How did I get test coins? Yeah, that's a good question. Well, I'm going to show you my Twitter conversation. I asked on Twitter, actually. I asked, I need test coins for default Signet network for Chain Code Labs lab on Friday. Please send to, and I added my address here. Thanks. And then someone suggested this signetfaucet.com. Well, that's one way to do it. So you can go to this one and enter a test Bitcoin address here and a desired amount, at most 0.1 test Bitcoin. But I wanted more. It's more fun to work with whole coins than fractions of coins. So I said that I would like to have bigger outputs. And then Anthony Towns responded and said he had sent me some coins. So he sent me a link to a blockchain explorer for my address. And there are 7 transactions here so far because I have experimented with it. Sorry, I'm confused here. There should be a very big, yeah, that's right. So sorry. I did do some Signet. I asked for some Signet coins here too. So that's for the same address. So so that's why I have several transactions before this main transaction from Anthony Towns. So this is Anthony's transaction, and he sent me 607 coins because he's such a nice guy. And someone asks, since it is a test net, why would a miner mine blocks for this network? Yes, that's a good question. Actually, there's only one miner for this. There can be several miners, but all blocks have to go through a central authority. And his name is Kalle Alm. As you can see here, this is the guy, Kalle Wolf. He's a Swede too, actually. But he's the guy who set up this network in the first place. And since this is just for test, it doesn't have to be absolutely censorship resistant. So he created this network, and I think anyone can mine blocks on it, but they also have to be signed by Kalle Alm, by Kalle Alm's node. so that he can control the block pace, the block rate, so that we get blocks in a on average 10 minutes apart. Because if we have a miner chain like this and we only do, and we mine as we do on proper Bitcoin, someone might easily spam the network with blocks because they are so easy to create. We don't want it to be expensive to mine blocks because because then no one would mine on it. Yeah, so it's just a test network, and Kalle Alm is the ultimate censor and authority in this blockchain. So reach out to him if you have complaints. No. Let's go back to our maybe. No, it's still unconfirmed. So we will go back to. I will stop sharing now. And from now, I think we can pause recording.